Engineering mechanics is the single most important subject for all engineers. Everything you learn here will be the foundation for many other design and analysis classes you'll be taking. So it is very important that you understand all of the major concepts in mechanics. Some of the concepts are not intuitive. It is more intuitive for a lot of people to think of Earth as a flat place and that sun rotates around it. But we know now this is not the case. Earth is round and we orbit the sun. If things were always obvious and intuitive, Newton's law would have developed hundreds of years before it was. So keep in mind, understanding these concepts may require a little bit of imagination, visualization, and experimentation. Engineering mechanics deals with the study of response of bodies under the action of forces. As engineers, we design and build things, and we have to make sure that things that we design perform exactly the way they are supposed to. An automobile, an airplane, your home, a bridge, an elevator, and a cell phone are all things made possible by engineering design. As you can see, failure of these systems is not only expensive, but may also be catastrophic. Engineering mechanics is the subject that helps us to study how these systems behave when forces are applied. For convenience, we divide mechanics into three parts: statics, dynamics, and mechanics of materials. In statics, we look at how a system performs under the actions of balanced forces. In other words, we study systems when they are in equilibrium. Examples of systems we study under the condition of equilibrium include everything from simple systems like tables, chairs, to more complex systems like massive bridges and skyscrapers. In dynamics, we look at bodies in motion under the actions of unbalanced forces. This means we are going to deal with systems that accelerate. When we go out for a run from standing, we apply forces so our body can accelerate. When we start driving, we start accelerating our car. When a plane takes off or lands, it is subjected to acceleration. We study all of this in this course. Dynamics has two distinct parts: kinematics and kinetics. Kinematics focuses on the study of motion. Let's start our discussion with that. When we say word motion, a few things come to our mind. Motion means movement from one location to another. For example, I am taking a step and thus I move from one point to another point. This movement causes change in position and covers a certain distance. We will call this displacement. It's obvious that it also takes a certain amount of time to complete this action. The time it has taken to cover this distance is speed. Speed is a term that we use in our life every day. For an example, I am driving my car and I'm going at 60 miles an hour. This is speed. If we can also include direction with speed, such as I'm going at 60 miles an hour north, then we will use the term velocity instead of speed. Speed is just a number, or also known as magnitude. But the term velocity includes the direction of movement. Velocity is a vector. The velocity also can change. It changes as the body goes faster, slows down, or changes the direction. The change in velocity is acceleration. In kinematics, we are going to deal with displacement, velocity, acceleration, and time. These are also called as kinematic quantities. In a nutshell, kinematics help us to find answers to the following questions: how far, how fast, how much faster, and how long. How far deals with the displacement, how fast deals with the velocity, how much faster deals with acceleration, how long deals with time. So in this session, we will study the relationship involving displacement, velocity, acceleration, and time. Let's now develop a few simple equations involving these parameters.